Okay, so here goes number 30 on page 141. So it says, show that the power rule for the derivatives apply to the rational powers of the form y equals x to the mn by raising both sides to the nth power and using implicit differentiation. So we need to prove that if we raise both sides to the nth power and differentiate, it's going to be the same as it would be if you just took the derivative using the power rule, took the derivative of x to the m over n power by just, like I said, using the power rule. So the first thing we're going to do here is just see what it actually equals when you raise both sides to the power of n and then differentiate. So that is the first thing that we're doing. We're going to raise both sides to the n power. So by doing that, because really when you do that, you're distributing a power of n to both sides, you're going to get y to the n equals x to the n. And then we differentiate. So when we differentiate, or now take the derivative, as you can see, you're going to use the power rule in both instances, but on the left-hand side, you are going to have that dy dx. So on the right-hand side, you just have your regular power rule used. So then there's a lot of algebraic manipulation that takes place, but basically we want to show that dy dx, or the derivative, is going to be the same as if we were to just differentiate that x to the mn power. So we solve for dy dx here. So in order to solve for dy dx, you need to divide by this whole guy on both sides, which I think I do. So, yep, I say solve for dy dx. Oop, and I didn't. So now I need to write a little bit. So we need to divide both sides by n, y to the n minus 1 power on both sides. And obviously that's going to cancel out on both sides. So now I'm left with, and I'm just going to write it down here, I'm left with the derivative is equal to m x to the m minus 1 power over n y to the n minus 1 power. So really the derivative is taken already, and as I have said many times in class before, the rest of it is just algebra. So I'm going to separate this fraction of m divided by n. So m, that's an m, divided by n. And I'm just going to have the x to the m minus 1 power in the numerator. And I'm going to have y, but y is already defined for us up at the top, which is x to the m n power. So I'm just going to substitute there. So it's going to be x to the m over n power, and that is being raised to the n minus 1 power. So what I'm going to do here is just use a bunch of power rules. So if I have a power raised to a power, I need to, which I have here in the denominator, I need to multiply them. But when I multiply, I'm going to distribute this mn to both terms of the n minus 1. So the first term, m over n times n, is just going to be m. And m over n times 1 is just going to be m over n. So this all ends up being that mn fraction still remains the same, this guy. And the numerator, it remains the same as it was over there. And the denominator is going to be x to the m minus m over n power. Well, now again, I just use another power rule where I have the same base, and I take this power and I'm going to subtract this power. It's just, again, one of your power rules. So that all turns out to be, the fraction, again, remains the same, m over n equals, not equals, I don't know how to erase here, so you're going to have to bear with me. X m minus 1 minus m minus m over n. So I think you could see that when you distribute the minus sign here, I'm going to get a plus m. I'm sorry, that's a minus m and then a plus m over n. So the m's are going to cancel. And if I could just move this down a little bit more. So the m's are going to cancel. The mn fraction on the outside remains the same. So what you're left with is x to the m over n power minus 1. And if you look at what we would have gotten to begin with by taking the derivative of this, well, that's just the power rule. So y prime is going to be m over n, x to the m over n minus 1 power. So it does work out.